But this is talking about a cane toad, which I think as my last name being Cane with a K instead of a C is pretty cute. But the cane toad is native to South America. It was introduced in Australia as a method of controlling apparently the sugar cane beetle. And this is totally true. So I'm not making this up because I'm not that creative. I guess I could have Mr. Cane make it up for me because he is pretty creative, but I'm not. I'll admit it. I'm only creative sometimes and not when it comes to coming up with fluff stuff like this. But anyway, so the cane toad was created to eat these beetles. So think of like different bugs that have been brought here, or spiders that have been brought here to kill other insects. So this is that same thing. The toad, though, has no natural predators, so nothing will eat it, and it secretes a poison when it's squeezed or bitten. They reproduce rapidly. So when it was introduced in June of 1935, they brought over 101 toads. Not even 2 years later, so 101 toads, June 1935. In March of 1937, there were 64,543 toads. And that was in, like what, a 20-month period, 21-month period. So the goal is for you to make a news story that explains to the people of Australia how the cane toad population is growing. It says include factual information that they would understand and that your math teacher would find significant. Graphs and tables are fine, but shouldn't be the only information that is given. So you should be able to plot a couple of points, create a graph, show a table, but you also should have an equation from the equation that we used in section 2 or 3.5. So this equation right here, y equals ae to the bx, that's the exponential growth equation that you are going to use. So you would kind of create ordered pairs, come up with an equation to match it. But then the rest of it, like you want to make it a news story, so make it interesting. Look this up, see if you can find out a little more information about it besides what I have in the description here. And it should look like a newspaper article, so kind of in that newspaper article format. So again, this is a different approach to a retest. Everybody can do it. Nobody can do it. You can choose to wait till after you take the test and feel what you're thinking, or maybe you're like, hey, I just want to do that anyway. But I'm going to give you 25 points for completing it, and then there will be some extra perks involved, depending on how above, I guess you would go, extra information that you would be adding into the story. Are there questions on this? This is due next Friday. So instead of a retest, it'll be due next Friday as if we were doing a retest. So just something different. If you have questions, send me an email or send me a chat and I can answer any of those questions. I'm trying to think last year, I have to look. I have a really good one from last year that was like, had some nice graphics, factual information. The equation was perfect. Trying to think who did it. I'll have to look to see who did it. There's a couple that were really good last year. I think Cade Gallagher did a good one last year. 2 years ago, not last year. 2 years ago, he did a good one. Anyway, so that is that assignment, optional. 25 points plus a couple of extra perks depending on how correct and interesting it is. So we are going to look at number 8 quickly from the homework. So if you want to pull out the homework assignment, this is just the review worksheet part. There were a couple of problems in the book as well that were part of the assignment, but this is the review worksheet here. So an initial deposit of $4,000 is made into a savings account with an interest compounded continuously. Important information there. The balance will triple in 15 years. What would the annual interest rate be? So if we want to solve this type of equation, Hannah, what equation or formula would we use, Hannah, to solve this?
You would you would do A equals 4,000 E to the R times 15.
Yeah, so we don't know the rate. That's what we're going to try and find. And then Hannah, what would the A value, what would that A value be if the balance is going to triple?
12,000.
Yeah, so we can replace that A with 12,000. So if we go to solve this, we would divide by 4,000. So we would have 3 equals E and then 15R. Remember, we're trying to find the rate. And then Hannah, how would you continue to solve this? So we have the 3 equals E to the 15R.
You would put it in log form, which would be ln 3 equals 15r.
Excellent. And then to get R by itself, divide by 15. So what'd you get for R? From the calculator, like directly from the calculator. What number did the calculator give you?
I got 0.073.
Yeah. So that is our numerical value, but this is asking for an interest rate. An interest rate you can see is given as a percentage. So if we create a percentage, it would be letter B, 7.3% numerical value. We have to change it back into percentage form. Any questions with that one? All right, so scrolling down to the bottom of that page, sorry, a little fast there. Number 10, a certain population grows with the equation y equals 40e to the 0.025t. Find the initial population and then the population to the nearest integer when t equals 50. So Darby, what would the initial population be here?
I said the initial population would be 40 because you would just plug a 0 in for t, which would cancel out the e, or I make the e 1, so 40 times 1 is 40.
Perfect. So plug a 0 in there for t. The initial time is when time is 0. Anything to the 0 power is 1, so you just get 40. And then Darby, if you're finding out when t is 50, what would you do?
So you would plug 50 in for the t, and then whenever you go to solve that, it would equal to 140.
Yeah, and rounding to the nearest integer. An integer is a whole number. So could be positive or negative. Of course, if we're talking about population, it should be positive. And then one more time, Darby, you're doing great. The last question, when will the population be equal to 60? So how would you approach that problem?
So I plugged 60 in for A, so it would be 60 is equal to 40e to the 0.025t. And then you would divide 40 by 60, so you'd get 6/4.
Or we could say 3/2.
Yeah. And then you would do ln of 3/2 is equal to 0.025t. And you would divide both sides by 0.025. And I got t is equal to 16 years.
Nice. And that last part, make sure you're labeling it. I was looking at homework. A lot of you didn't have that answer labeled. So it's about 16 years. Make sure you have that labeling for that information. The other two pieces, like they don't really say if this is, it says a certain population. So we don't know if it's a population of people or a population of deer or a population of bunnies. Like, I don't know. Could be anything. So I guess in theory, you wouldn't need to label those two pieces of information because we're not really sure what population we're talking about. Any questions on 10? All right, the last one. Number 17 was the last one you were asked to do. And this was similar to, I would say, 13, 17, and 19 in yesterday's book homework. Determine the annual rate of interest compounded continuously. Again, that little information there, for the sum of money in an account to become double the original amount after 10 years. So, Evan, do you know how you would set up this problem?
Wouldn't we use the A equals P to the E RT formula?
Yeah, what information could we plug in here?
I guess 2 for the P for the A.
Yeah, so 2.
And then a 1 for the P.
Awesome.
And then a 10 for the T.
Perfect. Nice job. So that doubling, A is 2 if I wanted to double, P is just 1. And then again, you're solving for rate here. So now this problem becomes similar to the previous problem. So this is really 2 equals e to the 10r. And just like the rest of them, we're taking the natural log of 2, setting that equal to 10r, and then dividing by 10. So the answer that you're going to get will be a decimal. And then you want to convert that to the actual rate. So it should be, after you convert it, make sure you're writing it as a percentage, because the rate of interest is what you're trying to find, which is our R value. So 6.9%. Any questions? Okay, so we are going to go to Kahoot. If you have the app already downloaded on your iPad, you can use that. Or you can just go to kahoot.it. And we'll see if we can get a little competition going on here. Apparently mine, it was up here. So I will say that you will want something to write on. So piece of paper, whatever you have. If you want a split screen, you could use a split screen. Sorry. Okay. Some of the questions are definitely a little tricky. So I know you want to be fast in Kahoot, but take your time. It is multiple choice, so make sure that you're not getting tricked by the answers that are given in the multiple choice form. And as I said, all of these questions will be posted for you to look at and review in case you get one wrong. That way you can kind of go back to it and look at it. Okay. All right, so you'll want a piece of paper or something to write on, and I think we are good to go. So 10 questions, we'll see, we have 20 minutes, we'll see if we get to all of them. So this is asking for the domain of the function. Be careful. So this is a log function. Feel free to place it in your calculator if you want, if that helps. Think about where the asymptote would be located. Oh, Miss Carp, this is a tricky one. So does anybody know why letter C is not the domain? What do you notice in the notation of that domain that's given?
Is it because there's not a parenthesis? It's a bracket.
Yeah, it's a bracket. Jack, what should it be?
2/5 to infinity, but like not including the 2/5.
Exactly, because that's where your asymptote is. So with the log function, to find the asymptote, you're going to set this parentheses equal to 0. Your asymptote is x equals form, but the asymptote cannot happen. So trick question from Mrs. Kane there. Now, at least tomorrow, it's not multiple choice. So hopefully you'll remember to put that parenthesis around.
I was just like, it's never the option none of these, so it's probably that one, and I just did it wrong.
Good thinking there, Jack. I like your reasoning. Mrs. Kane would never put that on there, so it must be the answer. He gets a little extra bonus because he had me last year, so we'll say that he had a little extra push there. All right, or Jack's just has good reasoning skills. I guess that's what it could be. And Evan, too. All right, Joe, good job. All right, try this one again. Just did a couple like this. Grant, did you get a haircut?
Yeah.
See, the camera helps. All right, nice job. So switching that to the natural log, solving for the t. Look at this next question here. So we just went over a problem like this. Find the number of years investing $2,000 to double. Almost identical to the problem we just went over. Good. Does anybody know what the answer should have been?
8.66.
Yeah, 8.66. Awesome. Good. Oh, Gianna's moving up on you, Joe. And Peter. Wow, Peter and Gianna are really close. All right, be careful with this one. Make sure it's completely simplified. There's a little trick in here too, so just be really careful. Again, make sure it's completely simplified. So thinking about those properties of natural logs. So this one definitely tricky, and I wrote it down on the iPad. I'm going to talk about it so you can kind of understand what's going on with this one. The exponent of 1/5 needs to be moved to the front. It does affect both of them. So the e cubed, it affects as well as the x. But there's a property of simplifying the natural log. So I have it on my iPad. When we're done, I'll pull back up my screen so we can talk about this problem here before we end class. Tricky problem. Oh, Peter and Jack, Caden, got some new leaders. So think about our properties of natural logs when it says to evaluate. Another way of saying simplify. Good. So when you have the natural log of e, whatever your power is would be your answer. Remember, they kind of cancel each other out. So it was the third property. So if we had the log base 3 of 3 to a power, it would be the power, or when it's the natural log of e to the exponent, whatever that exponent is, would be your simplified answer. So here's the function that you want to use. A math class was given an exam and then tested monthly with a similar exam. What is the average score after 5 months? So time here is in months. Our function represents the percentage on that math test after 5 months. Good. So plugging in 5 for t and then just simplifying that with your calculator, really. Taking 16 times the log of 6 and then taking 85 minus that value. That's called the human memory model, that function that was given. So after time, even though you're taking like a similar test, eventually after time, you kind of lose that material if you're not directly applying it or using it. What? Come on, ladies. I want to see some of you up here on the top of the scoreboard. All right, this is an equation here. We're solving for x. So natural log the quantity 7 minus x plus the natural log of 3x plus 5 equals the natural log of 24x. Think about when you have a natural log function, what has to happen with that answer. A bit of work involved in this problem. So hopefully you're condensing the natural logs on the left using that property. So 7/3, the other solution was -5. You cannot have negative values when you plug in a -5. It does not work on the right side of the equation. So that's why that one is not a solution. Make sure you're checking it on all sides, all parts
This
of it.
one was also on the homework last night, so I just checked there and got it.
Oh, look at that. You're remembering that it was directly pulled from the homework.
Yeah, number 7.
Number 7. Yeah, look at that. How about that? All right, we're going to do one more. Ooh, Jack's taking the lead. All right, so this will be the last one. This is now an exponential equation. So you see each kind of equation. Nice, very good. Good job. All right, so I am going to end our game because I do want to go over the one with the simplifying. So let's see who's on our podium here. Nice job, gentlemen. Some pretty good questions. And runners up, Kaden and Gianna. All right. Sorry. There we go. So hopefully that was helpful to kind of just go through some different problems using it a different form, different method. Oh, come on. There we go. All right, so I want to just show you that one problem. And this was the natural log problem. This might have been the fourth one, and the direction said to simplify. So the first thing I did was I took that radical and made it an exponent. And then we know that that exponent, that's called the power property, that it comes in front. So we would have e cubed times x. So the product property then says I would expand these. I'm going to keep the 1/5 outside, and then I'm expanding these by making it 2 separate natural logs and adding them together. So I'm just keeping the 1/5 out front, kind of worrying about that later. So the exponent of 3 inside can also move down. Or you could say, hey, I don't want to move that down because there's a property that directly relates to this part of the function or that part of the expression. What happens when you have the natural log of e raised to an exponent?
It simplifies to
Equal
just
their
the exponent.
Yeah, it simplifies to just the exponent. So the natural log of e, when it's raised to a power, is just the power. So that just becomes 3, and that's the little trick in this problem. So that is the third property that we talked about in section 3.2. And then this is still being multiplied by 1/5. So if I distribute the 1/5 through, we end up with 3/5 and then 1/5 natural log of x. So just be really careful with those properties, review the properties dealing with the exponents. So as I said, these questions and 2 more that we didn't get to are posted to Google Classroom. There are book problems as well. And I'm going to say that both of the assignments